Hello, scholars! Happy science! Happy science! Happy science! Happy science! What are we talking about today? Today, scholars, today we're going to understand, and we're going to continue to understand until we understand it, that matter has measurable. Remember, it can be measured. What can be measured? The physical properties. What are physical properties? They deal with our senses, and that these physical properties help us to determine how matter can be classified or broke into groups. What does classify mean? We break into groups. You get a group, and you get a group, and you get a group. We all get a group. Why? Because matter can be classified. And today we're going to do that by comparing solids, like we've already done, liquids, like we've already done, and today we're going to add a third. Have you ever wondered, have you ever had a moment where you have a plastic bag and you're wondering, why is it that if I stick my hand in and I pull my hand out, or if the bag is just sitting and it's a little bit open and I close it, why is it that the bag no longer, it feels like it's full? How can it be full when I don't see anything in there? Ladies and gentlemen, you have just discovered another state of matter. We know that we have our solids, and we know that solids are rigid and they have a fixed shape and they have a definite volume. The amount of space that they take up does not change. It occupies the same space every time. The matter of this spoon, the amount of matter in this spoon is not going to change. It's there. The popsicle stick was the same thing. The wooden wheel was the same thing. Matter that is solid has a rigid, fixed shape and a fixed volume, meaning it's not going to change. We talked about the liquids. We discovered that liquids and solids do have something in common. They have in common that both of them have a fixed volume. The amount of volume that is in this water container, it does not change. It's the same here. It's the same here. It's the same here. What does change is that it does not have a fixed shape. This water will take the shape of its container no matter what container I put it in. Right now, you'll see that it's kind of making almost a triangular slope down. But then when I slip it down here, it's going to take the shape of the bottom of the container. And if I turn it like this, it's going to take the shape of half of the container, because that's what liquids do. Liquids take the shape of their container. But the world is not just all solids. The world is not just all liquids. Wait, there's more. The world also has gases. And what is a gas? Gases, like liquids, are not rigid. Meaning, you can see I can change this bag. Now I've squeezed it in the middle, like there. I can squeeze it like this. I can squeeze it like this. I can squeeze it all kinds. If you have a bag right now, let's just close the top and squeeze them together. Move it all around so that you can see that liquids are not rigid. And just like liquids, they do not have a fixed shape. The shape changes. You see the shape of this bag? It's changing. It's changing. It's changing. It's changing. It's changing. But here's where liquids where gases are different. Yes, they are not rigid. Yes, they do not have a fixed shape, but they also do not have a fixed volume. So that means that the volume of the gases can change. And that's where gases are different. So watch this. I'm going to take this thing right here. We call this a balloon. Everybody knows a balloon. We know how balloons work. We know how balloons look. We know how to play with balloons. You probably hit it up in the air at some kind of a celebration. We all love balloons. Balloons are a solid, the plastic, that we can fill with a gas. It's actually carbon dioxide that we are blowing out of our mouths. We inhale oxygen, exhale carbon dioxide. We inhale oxygen, we exhale carbon dioxide. Yes, that's the way our respiratory system works. It's a little bit more advanced than that, but you'll learn about that in anatomy and physiology when you're a lot older. But I digress. Let's blow up this balloon. Notice the shape of the balloon is changing. Notice it's changing, but it's not fixed. I can still continue to change it. So as the gases are being pushed into this plastic balloon, the shape is changing, but it's not fixed, and it will continue to change. How can I prove that? I can continue to blow. And I can go on and on and on and on and on. And when it gets really, really cruel, I can prove that those gases are in there, because what's going to happen if I let this go? It's going to release the gas and fly all over the place. And that is so cool. If you have a balloon, please do it right now. Yes, blow it up and then just let it go and watch it go and smile the whole time, because science is awesome. What are we going to do today? Today, I want you to find pictures of solids, to find pictures of liquids, to find pictures of gases, and to share those, upload them to whatever your teacher has you hosting, or you could draw pictures of them in your journal, or you could find pictures of the same thing on the internet. Do what works for you, but get me pictures of solids, get me pictures of liquids, and get me pictures of gases. And then you're going to take what's called a triple Venn diagram. A triple Venn diagram is used to compare different objects. So this is the triple Venn diagram. This is what it would look like if we had our solids, our liquids, and our gases in there. On the top circle, you're going to write the characteristics that are just for solids. So I'm going to give you a hint. And I'm not going to tell you exactly what it is. I'm not going to tell you that solids have a fixed shape, meaning it doesn't change. I'm not going to tell you that, because if I tell you that, then you'll have the answer and you'll know what to put on your paper, okay? So I'm just not going to tell you. But in the circles that are shared, the circles like this piece right here, that's where we're going to put the things that are common between solids and liquids. So any characteristics that's the same between a solid and a liquid goes right here. Any characteristic that is the same between a liquid and a gas goes right here. Any characteristic that is the same or common amongst a gas and a solid goes right here. And if there is a characteristic that all three have in common, it literally goes right here. That's the way a triple Venn diagram works. Solid only, liquid only, gas only, liquid and gas, liquid and solid, solid and gas, and this is all three. And like I said, I'm not going to tell you, for example, that a solid has a definite shape. I just can't tell you that, because if I tell you that, you'll have the answer and you'll know what to write on your paper. So I just can't do it. I just can't do it. So stop trying to force me. I give up. I give up. That is our science for today. Hope you enjoyed it. Hope you learned a lot about classifying matter based on solids, liquids, and gases, because that's what we're here to do. We are here to understand that matter has measurable physical properties that help us to classify them into groups. Have a great day. We'll be back on with more soon.